Welcome back to another section of the Ultimate Docker course. In this section, we're going to explore containers in more detail. We'll talk about starting and stopping containers, publishing ports, viewing container logs, executing commands in running containers, removing containers, persisting data using volumes, and sharing source code with containers so we don't have to rebuild our image every time we make a change in our code. This is a short and sweet section, so let's jump in and get started. All right, we briefly talked about container commands throughout the course, so you're already familiar with many of them. In this section, we're going to review them one more time, but I'm also going to give you some extra tips along the way. For starters, let's look at our images. So I've cleaned up some of the images that I created in the previous section. Now we only have React App with the latest tag. We also have Ubuntu and Alpine, which we're not going to use in this section. Now, hopefully you completed the previous section, but if you didn't, I highly encourage you to download the zip file app attached to this lesson. In this zip file, you can find our React application as well as the Docker file that we created in the previous section. Use that Docker file to build an image, and now we are on the same page, okay? Now, question for you. How can we see the running containers? Using Docker what? Docker PS, short for processes, because a container is just a process, but it's a special kind of process because it has its own file system, which is provided by the image. Okay, currently there are no running containers here. So I want to run a new container using the React App image. This is going to start a development web server. So I'll be right back. Okay, our web server is ready. Now there's a problem. I cannot type any additional commands on the terminal window. If I press Ctrl and C to get out of this, our container stops. Let's verify that. So Docker PS, look, no container is running. So let me show you a cool technique. Let's bring up the run command one more time. Now this time we're going to use an option -d that is short for detached. With this, we can run this container in the detached mode, which means in the background. So look, that's it. Now the terminal window is free and we can do whatever we want. Of course, the container is going to take a few seconds to start because that's the time we need for the web server to start, okay? So that's one option. Now, let's look at the running processes. So here we have one container. Here's my container ID. Now, if you look on the far right column, which is not visible in my recording window, and I don't want to resize this window because the text is going to get small. In the last column, you can see the names column. So Docker automatically associates each container with a random name. So in the future, when we want to reference a container, we can either use its ID or its name. But we can also give our container a name when starting them. So let's start another container in detached mode. This time we're going to use --name to give it a name. I'm going to call this blue-sky. It's easier to work with than a randomly generated name by Docker. And we're going to use the React App image. Good. So let's look at the running containers. Now we have two containers and one of them is called Blue Sky. So now we have two containers running in the background, but there's a problem. We don't know what is going on inside these containers. What if something goes wrong? What if our server generates an error? That's where we need to use the log command. But first, let's bring up our running containers. So now we're going to look at the logs for this container. We type docker logs and then the container ID. Of course, on your machine, the container ID is different. So whatever it is, just type the first few letters. Okay, so here we can see the output of our web server. This is exactly the same output that we saw when we started this container in the foreground. Now, this logs command has some additional options. So as I told you before, whenever you want to play with the Docker command, always use --help to learn about various options. So one of the options here that is useful is -f or follow. This is useful if your container is continuously producing output. So instead of running Docker logs, some container ID multiple times, you can just use -f to follow the log. Then whatever is written to the log, you can see it in real time on the terminal. Of course, you have to press Ctrl and C to get out of that. Let's look at the other options. Another option is -n or tail. And with this, we can specify the number of lines to show. This is useful if we have a really long log. So Docker logs, what was that container ID? 655. I'm going to use -n5 to look at the last 5 lines. That's it. Pretty useful. Now, what if you want to see timestamps? We can use -t. So -t. And now we see the timestamp in front of each message. So if you encounter any issues when running your applications inside Docker, the first thing I want you to look at is the logs. Next, we're going to talk about publishing ports. So currently we have 2 containers running our React application. But if we go to localhost port 3000, we cannot access this application. Can you explain why? Because as I told you earlier, port 3000 is published on the container, not on the host. So on the same machine, we have multiple containers. Each of these containers is listening on port 3000, but the host itself is not listening on this port. So this port is currently closed. There is no way to send traffic into localhost at this port. This is where we need to publish a port. So first of all, let's look at our running containers. Now here we have a column called ports. Let me resize the window. It's going to look a little bit ugly, but bear with me. So we have wrapping here. Here's the ports column. In this column, you can see the ports and their mapping. As you can see, both these containers are listening to port 3000. Now I'm going to start a new container and publish a port at the same time. So just like before, we run docker run -d for detached. Here we're going to use another option called p, that is for port. We're going to publish a port on the host, let's say port 3000 to port 3000 of the container. And of course, these numbers don't have to be the same. So I can publish port 80 of the host to port 3000 of this container. Now I can give this container a name so we can identify it. I'm going to call this C1. Now, what image? React app. Good. So this is going to take a few seconds until our web server is ready. Now, if we go to localhost port 80, we can see our React application. Beautiful. Now, let's look at the running containers one more time. Now look at the port mapping for our C1 container. You can see port 80 of the host is mapped to port 3000 of the container. We do not have this notation for other containers. So you'll learn that when we start a container, it executes the default command that we specified in our Docker file. Now, what if you want to execute a command in a running container later on? Let's say we want to troubleshoot something and we want to look at the file system of that container. Let me show you how to do that. So we have docker exec or execute, and with this, we can execute a command in a running container. Now, some people say, what is the difference between docker exec and docker run? With docker run, we start a new container and run a command, whereas with docker exec, we execute a command in a running container, okay? Now, for this, I'm going to use my C1 container. This is the benefit of using friendly names. Now, what do we want to execute here? We can type any commands, any operating system commands. So this can be Linux commands or Windows commands. Let's run ls here. Now you can see the content of our app directory. But why the app directory? Can you explain why? Here's the answer. Because earlier in our Docker file, we set the working directory to the app directory. So when we run ls, we see the content of this directory, okay? Now, using the same command, we can open up a shell session. So we can say docker exec. We want to do this in the interactive mode so we can interact with it. Our container is C1 and the shell we want to run is sh. Good. So now we have a shell session inside this container. We can run ls. We can run print working directory. We can do anything we want. Now, when we're done, we type exit, and this doesn't impact the state of our container. Our container is still running. Let's verify it. Docker ps. So our C1 container is the first item you see here. So using the exit command, we can execute any commands in a running container. Earlier in the course, I told you that a container is like a lightweight virtual machine. So it can be stopped and then restarted. Let's see this in action. So I'm going to stop our C1 container. Good. Now let's verify that it's not running. It's not running anymore. Great. So now if you go back to our browser and refresh this page, look, our application is not available because that container that was serving this application is no longer running. It stopped. So we need to bring it back up. And that is very easy. We just type docker start C1. Now, what is the difference between docker start and docker run? With docker run, we start a new container, whereas with docker start, we start a stopped container. Okay? Next, we're going to talk about removing containers. There are two ways to remove a container. We can type docker container remove and then specify the name, or we can use the shortcut docker remove. I prefer this. So let's go with that. We get an error saying you cannot remove a running container. So here we have two options. One option is to stop the container and then remove it. The other option is to use the force option. So if you want to force the removal, we bring up the last command and type -f here. Okay, that container is gone. So let's look at the running containers. It's definitely not here. Now, how can we see the stop containers? Do you remember? Docker ps -all. Now, even though we have a bunch of containers here, that container C1 is not in this list. Now, let me show you a cool trick. Let's say you have so many containers here and you only want to look at C1. Here we can use piping. We talked about piping Linux commands earlier in the course. So we can say docker ps -a. Here we type a pipe and then use grep to filter by C1. Of course, this only works on Linux. So let's go with that. Look, we don't have a stub container called C1. Now here we also have the prune command. So docker container prune. And with this, we can get rid of all the stub containers in one go. Take a look. Good. So let's look at the running containers one more time. 2 containers here and all containers, 2 containers. Great. Next, we're going to talk about persisting data using volumes. Earlier in the course, I told you that each container has its own file system that is invisible to other containers. So let's do a quick experiment together. First, we look at the running containers. So on this machine, I'm running 2 containers. I want you to run 2 containers as well. So if you're not, start 2 containers from the React app image. Then I want you to start a shell session on the first container and write something to a file in the application directory. Then start a new shell session on the second container and see if that file is there or not. So pause the video and work on this for a minute. All right, here's my solution. We're going to run docker exec in the interactive mode. The container ID is 655, and we're going to run shell. Now here in the app directory, I'm going to echo data to data.txt. Now I'm going to terminate this session and start a new shell session on the second container. So 6EB. Good. Now I'm going to list all the files and I want to filter using grep to find all files that have data in their name. Nothing. So data is not here because each container has its own file system that is invisible to other containers. And that means if we delete this container, its file system will also go with it and we'll lose our data. So we should never store our data in a container's file system. That's what volumes are for. We'll talk about them next. Let's talk about volumes. A volume is a storage outside of containers. It can be a directory on the host or somewhere in the cloud. So let's see how we can work with volumes. We have this command, docker volume, that has a bunch of subcommands. So we can create volumes, we can inspect them, we can list them, we can also prune and remove them. So let's create a new volume called app data. And of course, we can call it anything. It doesn't really matter. Now let's inspect this volume. So docker volume inspect app data. Now here we have a bunch of properties. We can see when this volume was created. We can see the driver, which is local by default. That means this is a directory on the host. We also have drivers for creating volumes in the cloud. So if you use a cloud platform, you need to do your own research and find a driver for creating a volume in that cloud platform. Okay. Now look at mount point. This is where that directory is created on the host. So this is a Linux path. If you're on Windows, you would probably see something like C drive / program files, whatever. Now a note for my Mac users. Earlier in the course, I told you that Docker on Mac runs inside a lightweight Linux virtual machine. So this path that you see here is a path inside that virtual machine. It doesn't exist on your Mac. So if you try to go to this directory, you're not going to find anything, okay? So now we have a volume. Let's see how we can start a container and give it this volume for persisting data. So Docker run, you're going to run it in detached mode. I'm going to map, let's say port 4000 of the host to port 3000 of the container. Now we're going to use a new option, -v for volume. We're going to map app data to a directory in the file system of the container. So here we type a colon followed by an absolute path in the file system of the container. So we can go to /app/data. Now we don't have to explicitly create this volume before running this command. So if I type a new volume here, Docker will automatically create it. The same is true for this directory. Currently, we don't have a data directory inside our app directory. So Docker will automatically create this. But there's a problem with this. We'll talk about it in a second. So we give it a volume and then the image, React app. Good. So here's our container ID. Let's start a shell session. So Docker exec interactive 716 shell. Good. Now let's go to the data directory and write something to a file. So data to data.txt. We get a permission error. Can you explain why this is happening? I want you to pause the video and think about it for a few seconds. Here's the reason. Let's go out of this directory and get a long listing. So here's our data directory. Now look at the owner of this directory. It's the root user. And over here, as you can see, the owner is the only user that has write permission. So the app user, which is the user that runs our app, belongs to the others group. And in this group, we don't have a write permission. The reason we're facing this issue is because we let Docker automatically create this directory for us. So to prevent this from happening, we have to go to our Docker file. So back to our Docker file. After we create the app directory, we're going to run make dir data. We're going to create this directory using the app user that we set earlier in this file. With this directory will be owned by this user and it will automatically have the write permission. But now we have to rebuild our image because we have modified our Docker file. So let's get out of this. So Docker build -t React app period. Okay, our build was super fast, great. So let's start a new container. Docker run -t. This time I'm going to use a different port mapping. Let's say port 5000 of the host to 3000 of the container. And for volume, we're going to map app data to /app/data. But this time, the data directory already exists inside the file system of this container, and the app user owns this directory. Okay. Now we give it our image, which is React app. Good. Now let's run a shell session inside this container. So Docker exec interactive 007 shell. Now let's go to the data directory and write something over here. Perfect. Now here's the beauty of volumes. If I delete this container, this file will still exist because this directory is stored outside of this container. It's actually a directory on the host. Let's see that in action. So I'm going to exit and remove this container. So remove -force. You have to force it because this container is still running. 007. That's gone. Now let's start a new container with the same volume mapping. So this is a brand new container. Now we're going to run a shell session here. So Docker exec interactive e1c shell. Let's go to the data directory and list. Look, our data file is here. Beautiful. So volumes are the right way to persist data in Dockerized applications because they have different life cycles from containers. If we delete a container, the associated volume is not deleted. It still exists. Also, we can share a volume amongst multiple containers. Sometimes we need to copy files between the host and a container. For example, let's say we have this log file in our container and we want to bring it to the host and analyze it. So let's look at the running containers. All right, I'm going to go to this first container and create a log file in the application directory. Then I'm going to copy that file from the container to the host. So let's run docker exec interactive shell. Then here in the app directory, I'm going to echo hello to log.txt. So we have this log file inside the app directory, inside the container, and we want to copy it to the host. Let me show you how to do this. First, let's get out of here. Now, Docker has a copy command for this. Here we need to specify a source and a destination. In this case, our source is the container. Now here we add a colon and then type the full path to a file or directory. So we're going to go to our app directory and copy log.txt to where? We use a period to reference the current directory in the host, which is our project directory. Okay, now let's list the files. So here's our log file. Beautiful. Now we can also copy a file from the host to a container. So let's create a secret file here and copy it to the container. So echo hello to secret.txt. And of course, this only works on Linux to the best of my knowledge. If you're on Windows, you can just create a file using your favorite text editor. Okay. Now we have a file in our project directory in the host, and this file is not part of our version control system. It's not part of our Git repository. So we want to manually copy this file into the container. So I'm going to copy the container name one more time. So one more time, docker copy. Now this time the source is secret.txt and the destination is the container followed by a colon and the path /app. Done. Now let's run a shell session and list all the files. So here's our secret file inside the container's file system. So we have this React application available at localhost port 5000. Now let's see how we can publish our application changes. So back to VS Code, we're going to go to the public directory and open index.html. Here I'm going to update the title of this app to Dockerized React App. This title is what we see in the browser window. So let's save the changes. Now back in the browser, if we refresh, we don't see anything. We still see the old title. So what should we do here? Well, for production machines, we should always build a new image, tag it properly, and then deploy it. We'll talk about that later when we get to the deployment section. But what about development machines? We don't want to rebuild the image every time we make a tiny change in our code. That's just too time consuming. Now you might say, what about copying? Well, that's a pain in the butt as well. We don't want to manually copy files from our development machine into a container every time we change our code. So let me show you a cool trick. We can create a mapping or a binding between a directory on the host and a directory inside the container. So this way, any changes we make to any files in this directory are immediately visible inside the container. So back to the terminal, we're going to start a new container. Docker run -d. This time I'm going to use a different port so we can distinguish it. We're going to map this port to port 3000. Now earlier we used a volume mapping. So we mapped the app data volume to /app/data directory inside the container. Now using the same syntax, we can map a directory on the host to a directory inside the container. So instead of using a named volume, which is a directory that Docker manages, we're going to use the current directory, the directory that holds our application. So we don't want to type the full path here. This is where we use the pwd command, print working directory. Now, if we execute this command as is, Docker thinks this is a named volume. We don't want that. We want a full path. So we're going to wrap this with a $sign and put it in parentheses. Now, when we execute this command, this part of the command will be evaluated first, and the result will be a full path to the current working directory. Then we're going to map this to not the data directory. We're going to map it to the app directory inside the container. Okay. Now, what about a named volume? Well, we can still add another option and use a named volume here if we want to. But this React application doesn't really store anything on the disk. It doesn't have a database. It's just a basic front-end application. So we don't need a named volume here. Now, let's add the image. Good. So here's the container ID. Let's look at the logs. This time I'm going to use the follow option so we can see the changes as they come up. Okay, we're waiting for the web server to start, so I'll be right back. All right, our web server is ready. So let's go to localhost port 5001. All right, we can certainly see the updated title. Now, let's make one more change to the application's code. So I'm going to add an exclamation mark at the end. Save the changes. Now, back in the browser, I didn't even have to refresh. Look, we've got the exclamation mark here. Because in React, we have this feature called hot reloading. So whenever we change any of our files, our application gets automatically reloaded in the browser. Okay? So to share our source code with a container, once again, we use the volume option to map the project directory to a directory in the container's file system. Now you might say, but Mosh, running applications with Docker is a pain in the ass. We have to remember all these options and type them every time we want to run an application. No, you don't. In the next section, we're going to talk about Docker Compose, and you will see how easy it is to bring up an application with multiple components. I had to cover all these commands and options, so when we get to the next section, you know exactly how Docker Compose works under the hood. So I will see you in the next section.